Hi students, this is Mr. Yao. Today we're going to talk about 5.3b where we learn how to write proper proofs with parallel lines. First, before we actually want to write proofs, we need to know what kind of theorem, postulates, or properties we can actually use. First one, vertical angle theorem. That's something we have already talked about. Vertical angles are congruent, and in transversal, 1 and 4, 2 and 3, 5 and 8, 6 and 7, these are vertical angles. Next, corresponding angle theorem. So if a transversal intersects parallel lines, then corresponding angles are congruent. So as you can see, for the first few, they're all congruent, congruent, congruent. So the third one, alternate interior or exterior angle theorem. That's still congruent. And the fourth one, same side interior angle, and this is what I want to emphasize on. This one is supplementary. That's one thing. Also, this is the only postulate on this page. All the other ones, they're theorem, which means we actually have to kind of prove them and then make sure we can actually use them. But postulate, that means we can use them without doing any proof. So same side interior angle is a postulate. And that is the only postulate that we will talk about today. The other ones are all theorems. Next, we have a few more. We can also prove that lines are parallel based on the fact that certain angle pairs are congruent or supplementary. So basically, for all the theorems and postulates we just talked about, we can use them backwards. And they're called converse of, so for example, the first one, converse of corresponding angle theorem. If we have corresponding angles that are congruent, then we can say the lines are actually parallel. And the next one, converse of alternate interior or exterior angle theorem. You can see same thing, it still ends with lines are parallel. So if angles are the same, the lines are parallel. Next, converse of same side interior angle. Interior angle, again, that is the only postulates we have today. And still ends with the same thing. If they're supplementary, then the lines are actually parallel. So this time we can use the angle relationship to prove the lines are actually parallel to each other. Before I actually move on, let's make sure we know how to identify our parallel lines. So first question, which lines are parallel if 1 and 2 are congruent? The answer should actually be A and B, because, well, if you actually look at it, 1 and 2 are touching A and B. As for L and M, L has nothing to do with angle 1 or 2. And also for 1 and 2, it is because the converse of the corresponding angle theorem. These two are the corresponding angles. So next, we can actually have a look at a few more. First one, if angle 6 and 7 are congruent, again, there are corresponding angles, so we can clearly see there's that, and this is our transversal line. So M, L, and M, they're actually parallel. For the next one, we have 45 degrees. If you couldn't see quite clear, we just need to extend the line. We can clearly see there's a transversal there, so these two are actually corresponding angle of the CA and HR. So the choice is A. Now we can actually get into real geometry proofs. First one, given line A is parallel with line B, prove angle 1 and angle 8 are supplementary. So first step, A is parallel with B. That means we can actually get given, because that is given information. Next, angle 1 is congruent with angle 5. Angle 1 congruent with angle 5. They're corresponding angle. So instead of writing the whole thing out, we can just call it corresponding angle theorem. Next, the measurement of angle 1 and angle 5, they're the same. So that's definition of the congruence. Next, angle 5 and angle 8, they're supplementary. That is because of definition of linear pair. And since they are a linear pair, we can write the measurement of angle 5 plus the measurement of angle 8. That's 180 degrees. That's the definition of supplementary angle. And number 6, now since we already know 5 is the same as 1, we can replace that 5 as 1. So we have got measurement of angle 1 plus measurement angle 8 equals 180 degrees, and that is substitution. And since they're 180 degrees, we can say these two angles are supplementary. That is the definition of supplementary. That is example 1. Next, example 2. For all of these examples, I suggest you actually try them by yourself first before you actually keep watching the video. So first, A B is parallel with B, that's given. And based on that, we can get angle 3 and angle 2. They are supplementary. And that is same side interior angle postulate. Because we can see that's the parallel line, these two angles are actually same side interior. And C is parallel with D, that's given again, which means angle 1 and angle 2 are supplementary. Angle 1 and angle 2, that's the same reason, same side interior angle, not there, postulate. And because of that, angle 1 and angle 3 are actually congruent. We already know 3 and 2, 3 and 1 can actually take the same place. Call that either substitution property of equality. That's example 2. Next, example 3. L is parallel with M. We're trying to prove angle 4 is the same as angle 6. So maybe you're struggling with, well, you're fine with writing reasons, just reasons, but you might be struggling with writing the statements and the reason, basically writing the whole proof by yourself. So if you actually look at the question, the only information we know is M and L, they're parallel, and we're trying to prove 4 and 6. The only piece of extra information we have is this angle 3. That means we have to use them. And we always kind of start with a given. So L is parallel with M, that is given. And then we also actually can say the last statement, which is angle 4 is congruent with angle 6. So if we look at it, we're actually trying to prove alternate interior angle theorem. The only postulate that we can just use without actually proving is the same side interior. So we actually have a look at angle 3 and angle 6. They are same side interior. That means they actually form 180 degrees. And now if you actually look at 4 and 3, that's supplementary. They also form 180 degrees. And now that is kind of how we actually prove this question. We use the 180 degrees and we can actually replace things. So step 2 is angle 3 and angle 4 are they add up to 180 degrees. That's because of supplementary angle definition. And after that, we also see angle 3 and angle 6 are 180 degrees. That's because the same side interior angle postulate, they're same side interior angle. And because of that, we can actually say angle 3 plus angle 4 equals angle 3 plus angle 6, because they both equal to 180 degrees. So I'm using transitive property, which means A equals B equals C, so equals A equals C. Now for that, I can just subtract angle 3 from both sides, so subtraction property of equality. Measurement of angle 4 is the same as measurement of angle 6. And because they have the same measurement, the two angles are actually congruent. So that is definition of congruence. That is example 3. Next, example 4. This time we're proving the converse of alternate exterior angle theorem. So first, the reason is given. That means I just need to copy down whatever is given. Angle 1 is congruent with angle 7. 1 is congruent with 7. That is given. Next, 1 is congruent with 3. We can clearly see they are vertical angles. So that is going to be the vertical angle theorem. And because of that, 1 equals 3, 1 also equals 7. We can either call that substitution or transitive property of quality. Because angle 3 and angle 7 actually equal to each other, we can say that is that gives us L is parallel with M, that is converse of corresponding angle there. Because 3 and 7 are actually corresponding angles, so we can conclude they're parallel. So that's the two-column proof. We actually have other ways to write proofs, so I'm going to introduce you to a second way, which is called a flow proof. Here's how a flow proof look like for this example. We got angle 1 and angle equal is congruent with angle 7. That's given. The other piece of information is angle 3 and angle 1 are congruent because they're vertical angles. Both of these put together, if you actually look at our step 3, it actually came from the previous two steps to actually get that step, which is why when we actually do a flow proof, these two are going to point to the next step, which is angle 3 is congruent with angle 7, and that is the transitive property. And then, of course, the last thing is converse of corresponding angle theorem. So you can see that logic is the same, just the format is slightly different. I actually still prefer two-column proof because it's clearer. This flow chart, it works, but a lot of time, as you can see, we need to decide which level the statement is on. That statement is actually in the first level. It's in the same level as the given information because together they both give us our next step. So we actually write that in the next step. That would actually not be right. So flow proof has a setup situation compared to the two-column proofs, which might make things more complicated. But let's still try it out. So next, example 5. Complete the flow proof and the two-column proof. So first, angle 1 and angle 3 are supplementary. That clearly is given because that's the given information. Next, for B, definition of linear pair. So we're trying to prove A and B are actually parallel, and 1 and 3, they are supplementary. That's given information, and we can clearly see there's only one linear pair, which is angle 1 and angle 2. We can say angle 1, the measurement angle 1 plus the measurement of angle 2 equals 180 degrees. And for C, it said supplements of the same angle are congruent. Well, that actually is based from the same information. So you can clearly see from the previous step, angle 1 and angle 2 are actually supplementary. The reason that's supplementary definition. That's for C. Then for D, because angle 1 and angle 2 are supplementary, angle 1 and angle 3 are supplementary. So that basically they share the same angle. If that's the case, we can actually say angle 2 and angle 3 are actually congruent. And you can see the reason it actually used congruent, so we actually need to write it that way. And because angle 2 and angle 3 are congruent, we can conclude A is parallel with B, and that is by converse of corresponding angle there. So that's example 5, and that is the flow proof format. Now let's have a look at how we can write a two-column proof for this question. It's the same thing. Our first step is given. So angle 1 and angle 3 are supplementary. And the reason is given. And because of that, our step 2, we can have a look at the other pair. We can say angle 1 and angle 2 are supplementary. That's definition of pair. And because they're supplementary, we can actually say angle 1, the measurement angle 1 plus the measurement angle 3 equals 180 degrees. measurement of angle 1 plus measurement of angle 2 equals 180 degrees. And that is definition of supplementary. Step 4, because they both equal to 180 degrees, they both have the measurement of angle 1. We can actually say measurement of angle 2 is the same as measurement of angle 3, and that is transitive property of equality. And step 5, because they're the same, we can say angle 2 is congruent with angle 3. The reason I need to change into congruent is because the corresponding angle theorem says if two angles are congruent. It didn't say the two angles are equal. So that is definition of congruence. Lastly, because of that, I can say line A is parallel with line B, and that is converse of corresponding angle. There. That is example 5. Next, example 6. This question is going to look slightly different. It's asking us to use the two-column proof, but there's actually no extra information given, just a graph. We're trying to find the value of x for which A is parallel with B. So we can know our final conclusion is going to be A is parallel with B, but we do need to find our x value first. So we're kind of going to go backwards a little bit. If we're saying A is parallel with B, that basically means we can actually use that information. So if A is parallel with B, and for which, that means that's something we want to get to. We actually want it as a given information. So we can actually use that and say it's given. And then because it's given, we can say the two angles, we can call this angle 1 and angle 2. So angle 1 and angle 2 are supplementary. And that is same side interior angle postulate. Because of that, we can say measurement angle 1 and angle 2, they actually add up to 180 degrees. And that is definition of supplementary angle. And next, we are going to replace the 1 and 2. So we have 2x plus 9 plus 111 equals 180 degrees. And that is going to be substitution. Next, we are going to combine like terms. So 2x plus 120 is 180. That is going to be transitive property. You can either call that transitive or you can actually call that substitution, either way. And next, I'm going to subtract, so 2x equals 60. That is subtraction property of equality. Lastly, x equals 30. So that is going to be division property of equality. And that is the last example. That is everything for 5.3b. Thank you.